All right, let's do 3.1, which is domain and range. So domain are all possible x values, and always move from left to right. Think about the x-axis, that's on the left to right. The range are all the possible y values of a function. And this always moves, thinking the y-axis from the bottom to the top. When writing domain and range or using mapping, we always write from least to greatest. That's what left to right is, and bottom to top. So the smallest number to the biggest number. So we have the domain of the first one. These are from review. So domain is our x values. So I'm going to first label them out to see what is our smallest. It looks like -3. And when we have actual coordinates, just coordinates, we're going to label them out each individually. So -3, -2. Oh, and we also, I guess, never repeat. Never repeat values. That should also be there. So -3, write it once, -2, 1, and 3. When it comes to our range, we have 1, 0, 2, -4, -5. So we have -4, 0, 1, 2, and 5. No repeats. When it comes to table, to write the exact same thing, we have the x values of -3, -2. Actually, we're going to write -3 twice. So and -2, 1, and 3. It's just going to be exactly the same as, so -3, 5, -2, 0, 1, 2, and 3, -4. Mapping wise, we're actually going to do the exact same thing. So our first circle here is our mapping, is going to be -3, -2, 1, and 3. So do not repeat. The ranges, again, don't repeat them. So we're going to go -3 to 1, draw a little arrow. We're going to do -2 to 0, 1 to 2, and 3 to -4, and -3 to 5. A little shaky there. Now, coordinates, just drawing coordinates. So we go to -3, so left 3, and +1. -2, so left 2, up 0. +1 to the right, and then up 2. 3 to the right, 3, -4, so right 3, down 4. And -3, so left 3, and +5. Those are our coordinates. And so number 2, we'll write this pretty quickly. We have our domain or x values will always come first, x then y. Anything repeat? Nope. And then we look at least to greatest. So -2, -1, 0, 2, 5. Range value would be -3, 4, -2, 4, 1. So we have -3, -2, 1, and 4. When we're writing it out in a table, we just write our x values first, so it's always off our x, and then our y's will follow. So our x's go from least to greatest, our y's just follow what the x values are. So -2 is with -3, -1 is with 4, 0 is with -2, and 2 is with 4, and 5 is with 1. -2, -1, 0, 2, 5. I'm going to write -3, -2, 4, 1. So -2 is going to be with -3. So we're going to, with mapping, we can go from least to greatest because our arrows they are not always straight across like our table. These are coordinates, -2, -3. Where here we have like -1, 4, so it can go different than, like our arrow can go to a different angle, different number. 0 is with -2, 2 is with 4, and 5 is with 1. All right, plotting these points. To left 2, down 3 is 2, -2, -3. Left 1, so -1, +4. 0, -2, so 0 left and right, and down -2. 2 to the right, up 4, and 5 to the right, up 1. All right, moving on. All right, again, domain is all our possible x values, and they do move from left to right. Always look at the graph left to right, just like you're reading a book. Their notation, we always are going to use less than, so these are important. Less than or equal to, and they're always less than or equal to, and we'll talk about that a little bit more when we get to an actual problem. Range, all the possible y values, and the y-axis is a number line, and we're always going to write those least to greatest, and the smallest numbers on that y-axis is at the bottom, and then the biggest numbers are up top on the y's. And again, we write those with less than signs or less than or equal to. All right, so what I do, I'm going to take this graph. First, we're going to do domain. I'm going to take the graph, and I'm going to squish it down to the x-axis. So if I take this arrow on the left side and I bring it to the x-axis, it will look like a line here. If I take the V part, the bottom part, and move it up to the x-axis, all I'm going to do is I'm just going to redraw the graph on the x-axis if I take the whole V and squish it. The top part of the V, if I take that and move it to the x-axis, it'll be look like this. So now if I just read the x-axis, how far left is this graph going to go? Because we start with the left, and it's going to go to left forever. And forever is not a math term. Left is negative numbers, -1, -2, -3, and forever is -infinity. So we're going to start with -infinity. You can't actually get to -infinity, so it's not going to be equal to, it'll just be less than x values, because that's domain is x. Less than, and how far right will this graph go? Well, it'll go right forever. Right is positive numbers, 1, 2, 3, 4, 5, 6. So positive, and forever is infinity. Okay, now let's look at range values. I'm going to do the exact same thing. I'm going to take the V, and I'm going to squish it to the y-axis. So squishing it to y-axis, they're going to overlap. This left side is going to end up going to here. The right side, when we squish that over to the x-axis, it's going to go to here. And I'm going to read what I have written on the y-axis, sorry, y-axis. This is at -2, so the range is going to start at -2. There is an actual point of the V. That's the little minimum point of the V. That's going to be, there is an actual point there. So it's going to be equal to y, and then it's going to go up forever. All right, up is positive numbers on the y-axis, and positive and forever is infinity. So it's going to be positive infinity. You can't get to infinity, so not equal to. All right, number 4, I'm going to do the same thing. So for the domain, I'm going to squish that circle down to the x-axis and redraw it as just a line. And there we go. There's our line. Looks like it's going to go from the left side is -3. On the circle is an infinite amount of closed points, so that's going to be equal to, because the closed point's equal to domain, and it's going to go to the right to 3. And again, there's a point there, closed point, so 3. On the y-axis, I'm going to take the circle and squish it to the y-axis. Should look something like this. We got -3 to 3. Another way you could do it is how far left does the graph go, how far right does the graph go, and the lowest point to the highest point. Number 5, we have how far left does the graph go? Goes left forever to negative infinity. How far right does it go? Goes to the right forever to positive infinity. Or you could say all real numbers is another way of saying this. When it comes to the range, what's the lowest? The lowest the graph is going to go, it's going to go down to negative infinity. And how high is it going to go? It's going to go up to positive infinity. It's going to keep going up. Again, you could rewrite it just in words. It could say all real numbers. All right, number 6, we have what's the highest point of the graph here at 1, 2, 3, 4, 5. Before I do this, I got a little ahead of myself. How far left does the graph go? Or if you want to redraw it on the x-axis, if you squish it down to the x-axis, this graph would be one straight line, so it'd be negative infinity to infinity, or all real numbers. On the y-axis, the highest point is up there. If we take this graph and we squish that parabola, that's what that's called, to the y-axis, it would go down to negative infinity, so negative infinity less than y less than, that's 1, 2, 3, 4, 5. And there is an actual point. Remember, a graph is an infinite amount of closed points put together, so it's going to be equal to. All right, number 7, domain. How far left? Here's the leftmost point at negative 1. There's an actual point there, a coordinate, so it's going to be equal to x less than, and the farthest most right point of the graph is 1, 2, 3, 4, 5. There's an actual point there, so equal to. Range, the lowest y value, lowest point of the graph is down here at negative 3. And the highest point is up top at 3. Domain of our next point, how far left does the graph go? This leftmost point is going to go left forever to negative infinity. How far right will it go? It's going to keep going right. It's going to keep going right forever to infinity. Remember, this can be called all real numbers also. Range. It's the lowest the graph will go. This is going to go down forever to negative infinity. How high will it go? There's a little minimum point, local minimum, but it's not or maximum, but it's not the maximum of the graph. The graph goes up forever to infinity. Again, it's all real numbers. Number 9, we have the domain of this graph right here. Well, there's only one x value all the way along that whole vertical line. The x value is always at 2. This is like 2, 1, 2, 2, 2, 3, 2, 4. What do you notice? Well, the x values stayed at, whoa, Mr. Johnson. X values always stay the same. So that's our domain, is x is going to equal 2. That's all you can say about that. Range-wise, now this is totally different. How low does the graph go? Goes to negative infinity. How high will the graph go? The highest point? It'll keep going up to positive infinity. All right, let's look at number 10. This is going to be a little different. So how far left does the graph go? Left forever to negative infinity. How far right will it go? Well, it'll go right forever to positive infinity. Range. Now this is, what's the lowest y value? What's the highest point of the graph? Well, there's only one real point. You have negative 2, 0. Oh, wait, hold on. Totally read that wrong. That's up 1, 2, 3, 4. So that's 0, 4. This is 1, 4. We have, I'm going to skip, so that's 3, 4. What's in common with all of them? The y value is 4. It's the same thing that with all of them, so y is going to equal 4. All right, number 11. What's the leftmost point of the graph for domain? That's at negative 2. There's a closed point there, so it's equal to. And how far right will the graph go? Well, it goes all the way till, what is that x value? 1, 2, 3, 4, 5. And 5 is an open circle, it's a hole, so we are not gonna be equal to 5. Range, what's the lowest part of the graph? The lowest part of the graph is right here at 5, -2. What's the y value? -2. And that is gonna be not equal to, because it's a hole. And what's the highest point of the graph? The peak of the graph, the maximum point is up on top. And that's at 0, 1. So the y value is at 1. And there's an actual, remember, this is an infinite amount of closed points all the way along the whole graph. So a closed point is equal to 1. All right, domain of our next one, farthest most left point of the graph is over here at 1, -1, -2, -3, -4, 2. It's a closed point, so equal to. The farthest rightmost point is way over to the right here, and that's at the x value of 5. There is an actual closed point there, so we're going to equal to. Range, what's the lowest point of the graph? Down here, and that's at -3, -3. It's the range, so it's the y value, so -3. There's an actual closed point, so equal to. And the highest point of the graph is at 0, 5. And again, we're talking range, so that's the y value, and there's a closed point there, so 5. All right, come to class with any questions.